Okay, Chapter 2. How do hackers hack? What exactly is a hack? Now remember, there are only 10 types of people. Those who understand binary and those who don't. And those who count from 0. To know how hackers hack, we first need to know bugs. As you can see in that photo, that's the photo of a moth that crashed down the first computer. The computer actually used lamps that a bug get caught on and stop the computer from working, and that's where the word bug comes from. So software systems have flaws that we call bugs. A bug is an unaccounted situation in a software, which results in a misbehavior or crash of that software. So when a bug is found in a system, the system either crashes or does something that it's not intended to do. So a lot of software development goes into making systems that are designed to crash when bugs happen instead of doing something stupid. Because we want to have software that's first reliable in the sense that it does the right thing, then reliable in the sense that it actually works. So if it doesn't work properly, we would rather it not work at all. For example, a banking software. If instead of crashing, it transferred some money to someone else, we would never want it to do that. We would prefer if it crashed and the user told us that the system is not working and we fix it rather than have it. So that's why systems are designed in a way that they crash on bugs more frequently than misbehave. On average, there are about 15 to 50 bugs per 1,000 lines of code in each programming language. So why do we need bugs? And why are there bugs? Because programmers are human. They make mistakes. And there are different types of mistakes that they make. The first one is that they make assumptions that are not always true. For example, all names are smaller than 100 letters, as we'll see in a minute. Sometimes they just make stupid mistakes. They type something wrong. They forget to write or delete some piece of the code. And the last important thing is that testing everything is impossible because programs have infinite possibilities, which is an important theorem in computer science known as halting problem. A program has an infinite number of ways it can run, so we can't really test all of that. Now let's consider this simple code. This is a code in C. You don't really need to understand what it does, but I'm going to go over it because we're going to hack it in a minute, and so that you understand how hacking works and how you can hack this. We're also going to have an assignment in which you're going to hack the same code, so pay attention. This is a very simple program to enter username and PIN and transfer $1,000 if the username and PIN are correct. Let's go through it together. Let's start from line 29. This is the entrance to the program. It's called main. It's a function, it's a subprogram. It's a part of the program that executes. And main is the entrance point of the C programs. So this program in its main only does two things. It check pass and return 0. Return 0 basically means end the program. So this is not important. This is the end of the program. So check pass is the thing that this program does. And check pass is another subpart of this program. As you can see, this program has 3 subparts: transfer money, check pass, and main. So main calls check pass. Check pass runs and then returns and program terminates. So this is the gist of what the program does. Now we want to know what check pass does because that's the important function. That's the function that we want to hack. So check pass first introduces 2 variables, a username that can be at most 100 characters, can't be any more, and that's where the vulnerability, where the bug in this code exists. It also defines a number as check pin, which it wants to read from the user and check with the secret pin that we have up here, which is the pin required to transfer the money. Then it says to the user, enter your username, reads the username, then says the entered username was whatever we entered. Then it says enter the pin and reads the pin, and then checks the pin that it read, which is check pin, with the secret pin, which is the one that we have up there. And if they're equal, it says you entered the right pin, calls transfer money, which transfers the money, but in this case just says we transferred the money, but in real world it would actually do the transferring. And otherwise, if the entered pin is not correct, it says invalid pin, bye, and terminates the application. So an attacker would like to hack this code by running this transfer money without actually having the secret pin. That would be hacking. So the bug is that the code assumes username is 100 letters or less. Now let's run this code and we'll demo this. Okay, before that, let's go through this. Computers are designed to terminate misbehaving programs. As I said before, it's called a crash. All of you have seen this dialog on Windows. When a program starts misbehaving, Windows just shows you this and says this program is not responding properly, or it's too busy, or it's stuck somewhere. Let's just end it. And you can end that application. It does a couple of things. It ensures that other programs work fine so that this single program doesn't break the system down. And it also minimizes the damage to the data, which is the important thing. And the hardware, which is your computer, and the operating system, which is Windows, Linux, Mac, or other operating systems, do this for us. They don't like bad programs. They automatically close or kill these programs. Now, to exploit a program, we have to change the way a bug works. What if the bug could be used to change program behavior in a reasonable way instead of making it break? Oops. So that's what we call exploitation. That's abusing the bug to make the program behave in the way that the hacker wants instead of making it crash. So instead of using the bug to crash, you use the bug to change. It requires carefully crafted input because the bug is an unintended thing. We have to use that unintended thing to make the program do some other intended thing, which is basically the same as writing some program with our input. It requires deep understanding of how things work. That's why being a hacker is hard. And exactly how you exploit human-based systems, it's the same. You find a bug, understand the system, exploit it. The same thing happens in computer systems. Now, instead of providing a large input that breaks the program, in this case, as we'll see in the demo, what we want to do is provide an input that makes the program run, transfer money. It's called x86 stack exploitation. And we're going to see in a minute how this can be done.